Good morning, everyone. I hope everyone is good. Everyone is fine. Now, again, we are back with the next rapid revision session that is for hydrocarbon chapter. That is a very important chapter. I hope you all know that. If you just expect, like, how many of the question may come from this chapter? Easily, this may be two question, one question, two question. Easily, you can see from here. Sometimes even more, because it's very important chapter. Why it is very important? Because we all know that if you talk about organic compounds, then all the organic compounds are nothing but the derivatives of hydrocarbons. So to know hydrocarbon is of utmost importance. So let's talk about hydrocarbon. I think everyone you know about hydrocarbons. So today we will be just taking the reactions, or you can see the questions basically. The question that is based on whatever the reactions and theories is there. Okay, so let's not waste the time and directly go to the point. Now, if we talk about hydrocarbon, hydrocarbon is nothing but they are the compounds that contains carbon and hydrogen. How many types of are there? There are, if you talk about key classification into aliphatic hydrocarbons, and basically hydrocarbons are classified into aliphatic and aromatic. Now in aliphatic also, how can you say aliphatic hydrocarbons are of two types? One is saturated, another is unsaturated. What are unsaturated? Unsaturated where there will be pi bonds, or you can say double bond or triple bonds are present. Is it okay? I hope so. I hope everyone you have this idea, so I will not waste any time. Directly will come to the questions. Chaliye aaye. Now hydrocarbon A reacts with bromine by substitution to form an alkyl bromide. Okay. Now first of all, you can see that there is an hydrocarbon that is reacting with bromine, and that too with the substitution, not by addition. So you have to understand which hydrocarbon gives substitution reaction. So now the answer is very clear. Alkanes give substitution reaction, while alkene and alkyne give the addition reaction. So we can just say that okay, it is not the alkene or alkyne. It is what? Alkane. So because it is by substitution, so because it is by substitution, so therefore alkanes are there. Alkanes are there. No issues. So alkene, alkyne, not. Now bromide, which by Wood's reaction is converted to gaseous hydrocarbon. Okay, so Wood's reaction, I hope you all know that what you have to do. Alkyl halide is there, or haloalkane is there. What you will do? You will take sodium and dry ether. What you will do? In the presence of sodium and dry ether, this will convert into R. Basically, this is something how you can see. You can always just make it in the radical form and make this whatever is the 2RR will make the RR. Whatever is there, it is just the coupling of the alkyl part of alkyl halide. That is how you can simply understand. So basically, which kind of alkanes here can be formed? Here it can be symmetrical alkanes that can be formed through the Wood's reaction. Chalo aao zara dekhte hain. So Wood's reaction is converted into gaseous hydrocarbon containing less than 4 hydrocarbons. First question, can it react with bromine, or halogenation is possible? Yes or no? Yes. In the presence of HNu, in the presence of sunlight, or in the presence of heat. So always it will be given. So what will be there? Of course, we can see that this hydrogen and this hydrogen, both of them are same. Of course, both of them are equivalent hydrogen. So what we can say? Either you substitute this hydrogen or this hydrogen, not a big deal. So what this will convert into? CH3, CH2, Br. Okay. Now after that, what is happening here? It is telling that which by Wood's reaction. Now if you do the Wood's reaction here, Na with dry ether, what will happen? This will convert into, I hope you can see that here 2 carbons are there. So 2 carbon will convert into 4 carbon. How many? C4H10. 4 carbon ka alkane is how much? C4H10. So what it is giving? Converted to a gaseous hydrocarbon containing less than 4 hydrocarbons. But here how many carbons are there? 4. So of course this is not going to be the correct option. Now there is alkene, so not possible. Alkyne is there, not possible. So what we can say? Here it is, of course, methane. Methane in the presence of HNu and Br2, what it will convert into? CH3Br. In the presence of Wood's reaction, if it is happening, what will happen? CH3, not a big deal. Easy one, right? It's very easy. So there it is. Of course, we can see that number of carbon is less than 4. So option D is the most appropriate option. Next, the alkane that gives only one monochloro product on chlorination with chlorine in presence of diffuse sunlight. So basically you have to understand whenever you are halogenating or you are doing the halogenation of alkanes, you need sunlight. Okay. So now here what you are doing chlorination. Now isopentane. What you have to do in halogenation, of course, you have to know that CH bond will be broken and CCl bond will be or CX bond will be formed. Okay. So H ko todo, Cl ko lagao. So how many different types of H will be there? How that many different products can be formed? Yes or no? So what you have to do in such kind of question? Directly see the how many number of hydrogens are there. So that many number of halogenated product can be formed. चलो आओ जरा ध्यान से देखो. Isopentane. Isopentane will be 1, 2, 3, 4, 5. So how many number of hydrogens are there, or how many types of hydrogen are there? We have to see types of hydrogen. Types of hydrogen. Now here 1 type, 2 type, 3 type, 4 type. Here also both of them are equivalent. So how many? 4 types of hydrogen are there. Better we give them not 1, 2, 3, 4, but A, B, C, D. A type, B, C, D, D. So there are, I think, 4 types of hydrogen are there. Not a big deal. 2,2-dimethyl butane. चलो ध्यान से देखो. 2,2-dimethyl. 1, 2, 3, 4 butane. 2,2-dimethyl. चलो जरा देखो यहाँ पे how many number of hydrogen types of hydrogen are there? A, B. Here it is. Is there any hydrogen? No. यहाँ पर तो already this carbon has 4 bonds already formed. No. So there it is going to be C, C, C. So how many types of there are? There are 3 types. So 3 types means how many of the halogenated product will be there? You can say halo or chlorination product will be there. Chlorination product excluding you can say stereo isomers. See, whatever I'm answering excluding isomers, not including isomers. Okay. So चलो अब आगे देखते हैं. पहले इसको neopentane. Neopentane कैसा होगा? It will be something like this. C, 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 CH3. So basically, can you not say it is something like this? Acha, tell me, is there any hydrogen here? No. Is there any hydrogen here? Yes. Is it? अरे ये तो दोनों के दोनों क्या है? Equivalent space, equivalent. So all of them, all of these carbons are equivalent. So what we can say? How many types of hydrogen are there? 1. So how many types of products will be there? Here 4, here 3, here 1. So what it has asked? It has asked that gives only 1 monochloro product. So of course option C is going to be the correct option. Any doubt? No doubt, I hope so. A very easy type of question. Next, the correct statement regarding the comparison of staggered and eclipsed conformation of ethane. How ethane looks like and what is eclipse and what is staggered conformations. These are conformers. I hope you have to understand, though isomerism is not something that we have completed, but still I expect it to be that basics of that knowledge is there. So there are infinite possibilities of conformers, right? So how conformers can be formed? See, CH3. If you see Sawhorse or what we can say Newman, whatever projection you want to make, not an issue, right? चलो आओ जरा ध्यान से देखो. See, here what we have? CHH. It is what? Carbon HHH. Can you see? अब यहाँ पर both of the hydrogen are just face to face. Can you see? Face to face. So what we can say? Just if this is H, this is H, this is H, this is H. So both of them are eclipsing each other. So this is what? Eclipse. It is what? Eclipse form. What is staggered? Staggered means something that is just opposite. That is just opposite. Opposite का मतलब क्या हुआ? जरा ध्यान से देखना. Let's say H is there. So the backside carbon will have something like H, such kind of geometry. So in such case, what happens? Whatever is the torsional angle is there, so that will be maximum, and due to that the repulsion will be maximum, and due to the repulsion is maximum, so due to the repulsion will be minimum, and as the repulsion becomes minimum, the stability becomes maximum. So in such case, this is, or it is what? Anti or staggered. Anti or staggered. So anti or staggered are always more stable, more stable, or most stable, you can say most stable. While here we can see that both of them are closest to each other. So dihedral angle is here how much? 0 degrees. So as the dihedral angle is 0 degree, what we can say? Here the repulsion will be maximum. As the repulsion will be maximum, iski stability will be, because yahan repulsion is maximum, so therefore iski stability is minimum. Stability is minimum. Chalo aao zara dhyan se dekho. Now the staggered conformation of ethane is less stable. No. Staggered is more stable. No. Eclipse conformation of ethane is more stable. No. Yeah, eclipse, no, wrong. Eclipse conformation is ethane is more stable. Wrong. The staggered conformation of ethane is more stable, yes, than eclipse conformation, because staggered conformation has no torsional strain. Is that okay? I hope it is okay. Next, what about this? Again, this is a kind of question. What is that? These both of them are a pair of optical isomers. देखो यार, optical isomers वो show करेंगे जहाँ पे optical isomerism will be shown. Here we can see that there is, you know, a kind of symmetry. So because BrHCH3, though you can see that there is chiral carbon, but still both of them are symmetrical. There is symmetry. So because of the presence of symmetry, they may show or they may not show optical activity. So, but generally you will say that they will not show. What we can say that, so a pair of optical isomers, not a good deal to go with. Identical, no, you can never say that they are active, identical. A pair of conformers, yes, we can say that, as it is showing this way, because there is a single bond, and through single bond the bonds can rotate. Yes, as the rotation will take place, so conformational, these will be conformers of each other. In the following, most stable conformation of N-butane is, so where there will be minimum repulsion of the, can you see CH3, they are larger groups. As they are farthest from each other, so this will be the maximum stability. Can you see CH3? Both are farthest. If they are farthest, so what we can say? Their repulsion will be minimum. So stability will be maximum. Option B is the correct option, not a big deal. And this is nothing but this is anti, right? Next, आगे बढ़ो. Next is, which of the following conformer for the ethylene glycol is most stable? Always remember, only there is something called Gauss effect. What is Gauss effect? Before that, I would like to tell you few things here only. This is called anti-conformation. It is what? Anti or staggered. Anti or staggered. Can you see? This is anti to each other. That's why this is called anti. Every same groups are anti to each other. That's why it is called anti or staggered. It is most stable. Chalo dekho. Ab next kya hai? Can you see? There it is going to be just 60 degrees. So what we call it? We call it Gauss. What we call it? Gauss. It is called Gauss. Next. What is this? This is just eclipse. Same group back to each other. It is called eclipsed. Can you see? Here also one group is just behind another group. So it is also eclipsing, but not the same group is eclipsing. So this is called partially eclipsed. It is called partially eclipsed. So always remember, class, whenever there is a possibility of presence of hydrogen bonding, and hydrogen bonding only takes place when there is the distance is less, and in the Gauss case the distance is very less. So always remember, whenever there is hydrogen bonding possible inside, or intramolecular hydrogen bonding possible, and due to the intramolecular hydrogen bonding, what happens? There will be formation of the, you know, ring. As the ring will be formed, what will happen? Its stability will increase, right? As the stability will increase, and this stability only is there when there is Gauss. Maximum hydrogen bonding, extent of hydrogen bonding will be maximum at the Gauss position. So can you see OH? OH and OH are nothing but they are what? They are Gauss to each other. This is what? This is Gauss position. Gauss. So always remember, in the wherever there is hydrogen, intramolecular hydrogen bonding, intramolecular hydrogen bonding, there will be Gauss effect will be working. Gauss effect works. Gauss effect works, not a big deal. I hope you all can see that. Now you will say, sir, why OH here is, it is at the maximum distance, so it is anti, it should be more, but no, wherever there is hydrogen bonding, so due to the presence of hydrogen bonding, can you see that there is going to be, you know, there is going to be a ring formation, or so because of this, iski stability is here maximum. Stability is maximum. Can you see? Any doubt? No doubt. आइए आगे बढ़िए. Next, liquid hydrocarbons can be converted to mixture of gaseous hydrocarbon by See, whenever there are liquid hydrocarbons, always remember few of the physical properties or physical, few things like if carbon 1 to carbon 4 are generally gaseous. If you talk about carbon 5 to carbon 16, they are generally, or carbon 17, they are generally liquid, and carbon 17 and above, they are solids, that is waxy solids. Okay, so these are few, just sometimes up and down, a bit of possible is there, but the point is like this will be there. What is there? If you just take this part, agar aap ise, what you have to do that it breaks into smaller one. Basically what we can say, smaller ones are the gaseous ones, yes or no? Well, larger than these ones are liquid. So how do you break them into gaseous? So this is something that is called cracking or pyrolysis. Cracking or pyrolysis. How does this pyrolysis? The name itself is telling that there is pyro means fire. So with the help of fire or with the with the help of heat, you are going to crack something or break something. How does this happen? Let's say, as I can give you an example, like what to take. You may take C6H14. If you take C6H14, if you give 1000 degrees Celsius temperature, so this is liquid, but it will convert into many of the products. What are the products that you will see? You will see that there is forming C6H12. Also, you will get that C4H8. You will also get C2H2. You will also get C2H4. You will also get CH4. You will get a mixture of many gaseous and other smaller hydrocarbons. So this is nothing but this is called pyrolysis or cracking. Okay, so let's go further. Please read NCERT. Further reading expected from you. Next, a compound of molecular formula of C7H16 shows optical isomerism. Compound will be, okay, can you see there are all the compounds are given. When the optical isomerism is shown, always remember optical isomerism will be shown when there will be no symmetry element. No symmetry element. And second thing is there must be presence of chiral atom. Here we are going to see chiral carbon. Chalo zara dhyan se dekho. A compound of molecular formula. Let's make all of these. 2,3 dimethyl pentane. 2,3 1 3. So 2,3 dimethyl pentane. Is it, first of all, is there, can you see any kind of symmetry element here? I do not see. चलो क्या कुछ और possibility है? Let's see. क्या आपको दिख रहा है यहाँ पे क्या है? Hydrogen. Can you see here what is that? Methyl. Can you see it is what? Isopropyl. Can you see what is that? It is ethyl. It is what? Methyl. So can you see that this carbon is having one hydrogen, one methyl, one ethyl, one isopropyl. So this carbon is having what? It is having one chiral carbon, and there is no symmetry. So what we can say that this is going to be optically active. This is going to be optically active. Chalo. Next. 2,2-dimethyl butane. You can just check all of them. There will be no issue. Can you see that there is going to be no, not possible, because here also it is hydrogen. Here also it is hydrogen. Chiral carbon are those carbon where there all the atoms or all the groups are different. That is called chiral carbon. That's why I have just shown you this. Next. In commercial gasolines, the type of hydrocarbon which are more desirable is, okay, branched hydrocarbons. Yes, branched hydrocarbons. Please remember that whenever you take, basically, have you ever heard about octane number? Octane number is nothing. How do you increase the octane number? By branching or you can say by branching many of the, straight chain carbons into branched chain carbons. So in such case, what happens? Their octane number increases and they show less knocking, So it's a, it increases the efficiency of the fuel, and that is more desirable. Next, in free radical chlorination of methane, the chain initiating step involving the formation of, you have to know that whenever you start halogenation, first of all you have to take halogen. Let's say X2 is there, then you have to provide H nu. H nu is what? Heat. It will break this into free radical. Dekho, heat and H nu are considered as the free radical generator. They are considered as the free radical generator. So they are doing what? They are generating free radical like XX. So they will again now attack and they will start the whole chain reaction. So what is that? Chlorine free radical, formation of chlorine free radical. For sure it is the correct option. Now arrange the following in decreasing order of their boiling points: n-butane, 2-methyl-butane, n-pentane, 2,2-dimethyl propane. चलो देखो जरा, पहले तो बॉइलिंग पॉइंट का पूरा गेम समझो. व्हाट इज दैट? बॉइलिंग पॉइंट is directly proportional to number of carbons. The more the carbon will be there, the more the molar mass will be there. More the molar mass will be there, the more the van der Waals forces between the molecules will be there. The more the van der Waals forces will be there, the more will be the boiling point. Always remember, because van der Waals forces increase, so therefore boiling point also increase. Any doubt? I hope so that there is no doubt. चलो आगे बढ़ेंगे. Now if boiling point is directly proportional number of carbon, what else that that can increase or decrease the this boiling point? So boiling point is inversely proportional to branching. The more the branching is there, the lesser the boiling point will be there. So boiling point is inversely proportional to branching. What about n-butane? N-butane has how many number of carbon? 1, 2, 3, 4. N-butane. 2-methyl-butane. 2-methyl-butane means 1, 2, 3, 4, and there will be methyl at second position. N-pentane. N-pentane is for 1, 2, 3, 4, 5. What about that? 2,2-dimethyl propane. 1, 2, 3, and 2,2-dimethyl propane. चलो देखो जरा, how many number of carbons are there? Here are 4 carbons. Here are how many carbons? 5 carbon. Here are 5 carbons. Here are 5 carbons. But can you see that where there is least? First of all, least number of carbon is in first, so this is going to have the least boiling point. Second thing, because all of them contain same number of carbon, so you will have to see branching. Where maximum branching is there? Can you see here the maximum branching is there? Neopentane. So therefore this, its boiling point will be minimum, and then what will come? This iso, and then last n. So what we can say? Ki 3 is maximum. 3 is more than 2 is more than 4 is more than 1. 3, 2, 4, 1. 3, 2, 4, 1. Option 1. Okay, again. Arrange the following halogens F2Cl2 Br2 I2 in order of increasing reactivity with alkanes. देखो यार, alkanes के साथ reactivity के लिए always remember that F2 is maximum. It is so reactive. It is explosive in nature. It is explosive in nature. Explosive in nature. Okay. So maximum is F2, then Cl2, then Br2, then I2. So I2, Br2, Cl2, F2. Next, the correct IUPAC name of the following alkane is. चलो इनके लिए पहले देखो longest carbon chain कहाँ पे है? Longest carbon chain. Can you see? 1, 2, 3, 4, 5. No, 1, 2, 3, 4, 5, 6, 7, 8. 1. So okay. Anything else is possible? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8, 8. No issues. I hope it is going well. If you go by this way, how many of the, so number of carbon maximum is coming 8 only. But how many number of substituents you are getting? You are getting 3 substituents here, and that is a good thing. That is a good thing. So what we can say? This may be a possibility. Anything else? If you go 1, 2, 3, 4, 5, 6, 7, 8. In such case, only two substituents will be there. So it will not be a good thing. What we have to do? First of all, we should see the largest carbon chain, and second thing we have to see maximum number of substituents. So maximum number of locants should be available. I hope in this, how many of the locants are there? That is 3. So we can go with that. So what are the different locants we are having? Ethyl is there. Again, one more ethyl is there. One is methyl. From where we should go? Then you should lowest summation rule should be there. If you start from here, 1, 2, 3, 4, 5, 6, 7, 8. What will be there? It will be 6. It will be 8. 6, 8, 3. 6 plus 8 plus 3. This will give you how much? 17. But what if you start from here? Consider. अभी ये हटाओ और उल्टा सोचो. If you start from here, 1, 2, 3, 4, 5, 6, 7, 8. So what are these? So methyl at second position, this ethyl at third position, and this ethyl at sixth position. So can you see what is that? This is 11. I think 11 is the lowest number, so of course we should go by that. So 2-methyl is there, so it is 2-methyl is there, and 3 and 6-diethyl is there. So 3,6-diethyl 2-methyl, 3,6-diethyl 2-methyl octane is the correct option. Any doubt? I hope so. There is no doubt. Any dikkat? So I have talked about all the rules. First of all, you have to see the longest carbon chain. Then you have to see that where the maximum number of locants are there. Third thing, least, when you are numbering, so number from that side where the lowest summation rule is being followed. So least number should be followed by their location. Okay, I hope you understand it. The addition of HBr to 1-butene gives the mixture of product A, B and C. Okay, 1-butene. How 1-butene looks like? 1-butene something looks like that. What you are doing? You are going to do HBr. HBr तुम क्या करने जा रहे हो इसमें? Add करने जा रहे हो. What you have to do here? The HBr is going to be added. So can you see that this is what? I hope you all can see that this is alkene that is unsymmetrical, and you are adding one HX into it. Once you are adding HX into it, what will be something that follows here? I hope you all remember Marconi-Koff rule. But Marconi-Koff rule use करने से पहले हमेशा याद रखना carbocation का rearrangement very important. First of all, you see the carbocation rearrangement. If something else is more stable, कहीं पे पॉजिटिव सबसे ज्यादा स्टेबल हो रहा है तो वो करने के बाद ही Br माइनस को अटैच करना, अदरवाइज नो. चलो जरा ध्यान से देखो यहाँ पर. आई होप यू ऑल कैन सी, नॉट अ बिग डील. यहाँ पर सीधा तुम करोगे. ऑफ कोर्स वी सी दैट हियर पॉजिटिव इज गोइंग टू बी मोर स्टेबल एंड हियर नेगेटिव इज गोइंग टू बी मोर स्टेबल. ऐसे समझ लो कि इसको ऐसे ब्रेक करो कि you are doing it minus, you are doing it positive. Why positive here? Because can you see that this is plus I effect. This plus I effect will stabilize it. This is just a way to explain. It is not the reality. The whole mechanism is different. So just understand it. What you have to do, what are the things you have? H plus Br minus. So Br minus will be going towards positive and H plus will be going towards negative. What you can see? So Br will be somewhere here. You can just here put Br, right? तो चलो भाई Br को वहां पर रखो तो क्या हो जाएगा? अच्छा, what it is asking? Okay, ठीक है, A, B, C. So these are the products that forms. अच्छा, it is talking about the major mixture of product A and B and C. The addition of product A, B, C. The mixture consists of. अच्छा, what is the major? अच्छा, it is asking for major. So I hope you all understand that this is going to be major, while minor part will be there. Minor part ऐसा होगा कि Br will be coming as that position where there is maximum number of hydrogen. Marconi-Koff rule क्या बोलता है? That negative part of the addendum goes to that part where there is least number of hydrogen. So जरा ध्यान से देखो तो यहाँ पे कितना हाइड्रोजन है? 2. यहाँ पे कितना हाइड्रोजन है? 1. So Br will come at this place, but hydrogen will come at that place. Okay, no issues. But if you think just opposite, what else is possible? One more possibility is there. This one possibility कि Br will come here, hydrogen will come here, but this will be minor. This will be minor product. So can you see that this is nothing but 1, 2, 3, 4 and 1 Br at last. So this is minor. C is minor, while AB nothing but it is, ये क्या है? Can you see that this is optically active? It is what? Optically active, because there is chiral carbon. So this will have D and L form, both of them in the 50-50% ratio. So A and B will be major while C will be minimum. So A and B as major and C as minor product. It is a very good question. Please note it down, and very beautiful question. Next, which of the following reactions of methane is incomplete combustion? Can you see what we have to do? CH4. If you do the complete combustion, it converts into CO2 and H2O, right? Chalo dekho. So CH4 plus O2 converting into, it is oxidative. It is what? Oxidative. Or you can say that it is one of the ways of doing combustion of methane. Then M2O3 converting into HCHO plus H2O. It is also one of the incomplete one. What we can say? CH4 plus O2, carbon plus H2O. Acha, which of the following reaction is methane is incomplete? So of course here what is happening? There it is complete. Acha, here also incomplete it is asking for. So CH4 plus O2 converting into C plus H2O. There it is what? Because it is not giving carbon dioxide, so therefore it is what? Incomplete combustion. Which of the following reagent is best suitable for the below conversion? What is there? Can you see? OH is there and C double bond O converting into CH2. C double bond O converts into CH2. When this happens in the presence of, I hope you all remember that either you will use zinc Hg concentrated HCl Clemenson reduction, or you will use, can you see, Wolff-Kishner NH2 NaOH. But here what will be sufficient or better? Hi and red phosphorus. Because what Hi and red phosphorus does, it will break all the CO bonds. And it will reduce it. So what it will do, it will break this also, it will give H2O. इसको अभी हटा देगा, इसको भी हटा देगा. So it will convert directly into, if you, let's say, if you are going to give red phosphorus and Hi, what it will convert into directly? Cyclopentane. But we do not want cyclopentane. We have to keep this OH intact, means something that does not react with this OH. But can you see that zinc concentrated in HCl is there? So H plus and Cl minus. Can you see oxygen here has lone pairs? So this lone pair will, because it is what? This is nucleophile. So what will happen? This will attack on nucleophile. It will convert into OH2 plus. So because this HCl is there, so there is acidic part is there, and OH is nothing but, you have to keep in mind that OH is acid sensitive group, acid sensitive group. So you should not use such kind of reducing agent that is having acid into it. So no, do not use it. So is there anything that has base? I hope you all can see the NH2. This is a better one to go with. So option C is the best option to go with. Okay. Now, in which of the following alkane can be oxidized to corresponding alcohols by KMNO4? Chalo, dekhte hain. Just a minute. Yes. So, in this case, in which of the following alkanes can be oxidized to corresponding alcohols? Now, alkanes ka oxidation is not so easy. First of all, please remember that 1 degree, 2 degree alkanes do not undergo oxidation. Batao. But 3 degree alkane, where there is 3 degree hydrogen is present. समझ रहे हो? जहां पे 3 degree hydrogen is present, वहां पर this may give oxidation. Oxidation to what? जहां पे भी CH bond होगा, CH bond, if you give it, if it is, let's say, 3 degree carbon CH bond, then if you give it KMNO4, it will convert into COH bond. Okay, it will convert into COH. चलो आओ जरा ध्यान से देखा जाए. What do I mean to say if I say this? चलो आओ जरा ध्यान से देखो. Neopentane 1, 2, 3, 4. Can you see this carbon? इस carbon पे कोई भी, can you see it is, no, it is quaternary carbon and it is not having any hydrogen. अगर कोई hydrogen ही नहीं है तो oxidize कैसे होगा? No. And all other are 1 degree. तो अब बात ही छोड़ो. Methane CHHHH. No, super primary. Isobutane 1, 2, 3, 4. Can you see this carbon having CH3? Can you see this hydrogen? This is 3 degree hydrogen. Of course 3 degree hydrogen is there. So what will happen? If you give KMNO4, what it will convert into? It will convert into alcohol, 3 degree alcohol. So option C is the correct option. Okay, any doubt? I hope so. It is very clear. How much volume of air will be needed to complete combustion of 10 liter of ethane? अच्छा आओ देखो. Always remember, ethane is a gas or liquid. It is gas. एक बात याद रखना, gases according to mole concept में तुम लोगों ने पढ़ा होगा that gas and volume, moles and volume for gases go in same proportion. मतलब always remember, if moles becomes double, the volume will also become double. Okay, simple thing you have to keep in mind. So what we can see that ethane C2H6, you should know how to write the combustion reaction. Carbon will convert into carbon dioxide, hydrogen will convert into water, H2O. How many of the hydrogen is there? 3. So how much of water should be there? 3. How many oxygen comes? 2 to the 4, 4, 3, 7. So how many of O2 should be there? 7/2. This is the reaction that we have. Now always remember, 1 mole needs 7/2 moles of oxygen. What is needed? How much volume of air? Okay, it is asking for air. It is not asking for oxygen. Air. Okay. Consider air has 20% of O2. Consider, because 21, so 80%. Can you see? So 80% will not be taking part in the reaction. So 20% of oxygen is there inside the air. चलो पहले तो ये समझो कि if you are taking 1 mole needs 7/2. So what we can say, if 20 moles you are taking, so 20 into 7/2, that is how much? that is 70 of 20 moles you have taken, it will need 70 moles. Okay. Yeah, just a minute. 1 mole reacts with 7/2 moles of how much volume of air will be needed to 10 liter. Sorry. It is asking for 10 liter, right? So 10 liter will be needed. Sorry, I do not know. 10 into 7/2 cancel 5. 5 7 35 liter. Basically, if it is telling you 35 liters, you have to understand 35 liter of O2. 35 liter of O2. But how much of air is there? Though it has not given, if it is considered that air is oxygen, then answer will be D. But what if it is not considering this, but air contains only 20%? So how much of the air will be there? Air should be 5 times of volume of oxygen. So volume of air should be, because you have to take 100%. 100% is 5 times of 20%. So there should be volume of air should be 5 times more. So we can say that 5 into 35, 5 3 is 150 plus, that is 175 liter. So option correct one should be 175. When 35 liter of O2, but 175 liter of air. We have to keep in mind, please, because we know that here percentage of oxygen is how much? 20%. Or you can just use that formula, that percentage volume percentage of O2 equals to volume of O2 divided by volume of air into 100. Now we know that volume percentage of O2 is how much? 20. Volume of O2 we have got how much? 35. We want volume of air. How can you do? Volume of air will come out as 35 into 100 divided by 20. Cancel how many times? 5. It will come how much? 175 liters. So you can do anything from any ways, you can get the same answer. The number of isomeric sodium salt of carboxylic acid that can give neopentane when treated with soda lime. Neopentane. You want neopentane. How can you get? Always remember RCOOH or RCOONA. If you just do soda lime like NaOH plus CaO, if you are going to do this reaction, what it will convert into? Always remember this carbon dioxide को तुम्हें क्या करना होता है? Remove carbon dioxide. Basically have to directly form RH. What do you have to form? RH. Whatever is this R, उसका तुम हाइड्रोजन लगा करके एल्केन बना दो. समझ रहे हो? So what else साथ में बनता है? Na2CO3. दो उसको छोड़ो. तुम्हें इससे मतलब है कि क्या बनता है? एल्केन. So what you have to form? You have to form this. So how do you get this? By making extra carbon dioxide, C double bond OOH. So एक acid ऐसा बनाओ जिसमें एक extra carbon. Can you see after carboxylation 1 carbon is decreasing. So for neopentane, how many of the COH should be there? 1 extra COH should be added. Can you see all these carbons are again the same kind of question when what we thought of halogenation time. Same, all the carbons are symmetrical carbons. So wherever you just put COOH, it will be giving same molecule. So whatever will be molecule, it will be same molecule. So how many of the possible isomers are there? Only one. Either you put here or here or here or here. Everywhere it will be same. If you do NaOH plus CaO, what will happen? CO2 will be removed and there will be formation of, you see, what will be there? Neopentane will be there. Any doubt? Option B is the correct option. Next. Now we have come to the alkene. Alkane part is already done. Okay. Now we have come to the alkene part. Alkenes, I hope you understand what is the general formula. CnH2n. That's it. While for alkane it was CnH2n plus 2. For alkyne it will be CnH2n minus 2. Chalo, be faster because there is whole aromatic part and this part is also there. So how to make it and what are the different types of reaction? Always remember that alkanes give substitution reaction. While what about that? Alkene gives, what will happen? Alkene will give the electrophilic addition reaction. Alkene, not just alkene, and alkyne also. Alkyne also. And what about benzene ring? If you talk about benzene ring will give electrophilic substitution reaction. I hope these things you already know. That's why we are there in the revision class. Now this is the reaction concentrated H2SO4. If you are taking concentrated H2SO4 and heat, means there it wants to tell you about the elimination reaction. It wants to talk about elimination. Acha, elimination, that too of alcohol, and that too here which kind of elimination will take place? Beta elimination. Can you see OH? Can you see there is beta carbon, but is there any hydrogen here? No. So there is not going to be any elimination from this carbon. Is there any hydrogen? Yes. So one OH and one H. What will be there? One OH and one H will be removing, and here will be a double bond will be coming. So what we can say that beta elimination you have to do. So here C, CH3, 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 CH, double bond, CH2. This should be the correct option here. I hope you option A is the next answer one. Find correct order of reactivity of alkene towards HBr. HBr कैसे react करता है? I hope you have to understand what is the whole process of HBr के साथ का reaction. Let's say R, C, H, double bond, CH2 is there. So if HBr is going to react with each other, just think in this way कि first of all there will be electrophile that will be attacking on it. So what is electrophile here? H plus. H plus will be attacking on it. So basically electrophile attack नहीं करता, attack करते हैं हमारे loosely bonded pi electrons. Loosely bonded pi electrons will be converted or attacking onto H plus. What it will convert into? R, C. जैसे ही यहाँ पर समझ लो, ऐसे समझ लो, CH. Once this will take H plus, so this will break. This bond will be broken in such a way that it gets the positive, more stable positive charge. So where positive is more stable, here or here? I hope you will see that it is going to be more stable because R is here, plus I. Plus I will increase the stability of carbocation. Yes or no? So of course I hope you understand कि positive यहाँ पे आना is better. I hope you all understand. जबकि यहाँ पे positive आना is not good. So what we can say? CH positive. Here what will happen? CH2. So after that what will happen? So basically what is the main thing we have to understand? That there is going to be formation of carbocation. अब कार्बोकेटाइन कब सबसे स्टेबल बनेगा? आई होप दिस इज ओनली यू हैव टू सी. सो वेयर द कार्बोकेटाइन विल बी मोस्ट स्टेबल फॉर्मेशन, कि यहाँ पर जरा सोचो, ये अगर CH3 हो गया, यहाँ पे प्लस हो गया, so this is what? This is 3 degree carbocation, 3 degree carbocation. So that is most stable. Can you see here? Here it is going to be, if you take negative, here it is going to be positive, or you make it CH3. So what will happen? Here it is 2 degree, 2 degree. But what about this? Can you see here? Because both of them are same, negative. Here it is going to be, or make it CH2 and make it here positive. Can you see here? There is, more stability from both the sides. So in such case, what will happen? In such case, we can say that maximum will be for 3. 3 is going to be maximum because here more stability, you understand it, because of 3 degree carbocation. Now 3 is more than 3 is more than 3 is more than 4, 3 is more than 4 is more than 2 is more than 1. Option D is the correct option without any doubt. सोचना ही नहीं है बहुत ज्यादा, डायरेक्टली अब यहाँ से Br माइनस का अटैक करा करके R CH Br CH2 बना दो. आगे बढ़ो. Next we are going towards the most suitable reagent for the following conversion. Can you see here there is triple bond, so therefore alkyne is there. अच्छा देखो ये थोड़ा गड़बड़ है. Triple bond is there. Triple bond CH3C, triple bond C CH3. Now it is converting into cis 2 butene. अच्छा देख रहे हो, एक बॉन्ड, one bond is going to be broken. अच्छा ब्रेक करने के लिए क्या करोगे? इसे हाइड्रोजिनेट करने वाले हो, मीन्स यू आर गोइंग टू हाइड्रोजिनेट इट. अब देखो हाइड्रोजिनेशन के लिए हमारे दो टाइप के रिएक्शन होते हैं यहाँ पर. विच काइंड ऑफ रिएक्शन आर देयर? 2 टाइप्स ऑफ रिएक्शन. और यू आर गोइंग टू अब यहाँ पे तुम्हें एक बॉन्ड ब्रेक करना है. यू हैव टू गिव हाइड्रोजन एंड हाइड्रोजन. देयर आर 2 पॉसिबिलिटीज. वन इज बाय द लिंडलार कैटलिस्ट और बाय द बर्च रिडक्शन. बर्च रिडक्शन से क्या करोगे? वहां पर आपका एंटी बनता है या फिर तुम बोलो ट्रांस बनता है, जबकि यहां पर क्या होता है? जब भी आप लिंडलार कैटलिस्ट यूज करोगे इट विल बी सिस. अब कहां पे है? H2PD BaSO4 और H2PD कार्बन क्विनोलिन. सो दिस इज व्हाट आई होप यू ऑल अंडरस्टैंड इट. लिंडलार्स कैटलिस्ट that gives cis alkene, like, but with the, can you see liquid liquid sodium and liquid ammonia, this is Birch reduction, and Birch reduction mein it gives trans alkene. So these things are very easy and very important to keep in mind. An alkene on ozonolysis gives methanol, as on the product its structure is. Can you see? ओजोनोलिसिस करते हो तो क्या होता है? आई लेट मी टेल यू. ओजोनोलिसिस देयर, ऐसे बस ब्रेक करो. ओजोनोलिसिस, इसको ऑक्सीजन दे दो, इसको ऑक्सीजन. वेरेवर देयर इज डबल बॉन्ड, ब्रेक दैट, गिव ऑक्सीजन टू इट, ऑक्सीजन टू इट. इफ इट इज रिडक्टिव ओजोनोलिसिस, तो ओजोनोलिसिस दिया है मतलब कंसीडर इट इज रिडक्टिव ओजोनोलिसिस ओनली. सो मिथेनॉल एज द प्रोडक्ट. Will you get any methanol here? No, you will not get any methanol here. C double bond OH. No, it will not get. You will not get methanol because it will convert into something like that. Can you see how many? It is propyl is there, and then it will convert into OH. OH. So is it what? Can you see? Is there methanol? No. Can you see? Yes. Here it is going to be. Give O. Give O. What it will convert into? H. C double bond O. H. Can you see what will happen? Here it will convert into C H to C double bond O H. So there it is what? Methanol. So option B is the correct option. Not a big deal. यहाँ पे भी करोगे तो C double bond O वो भी नहीं होगा. No. Here it is going to be, can you see? Ethanol, not methanol. Next, an alkane A on reaction with ozone and zinc H2O gives propanol and ethanol on equimolar reaction. Okay. What do you have to get? Propanone. How do you write propanone? Propanone. So 1, 2, 3 propanone. Okay. And ethanol. Ethanol matlab समझो 1, 2 H. So it is what? Acetaldehyde and acetone. You have to form. चलो देखो हमेशा याद रखो. Wherever how you make this? Wherever is double bond ना, इसके double bond हो, इसके double bond को चिपका दो. Just match both of them. देखो मैं क्या बोल रहा हूँ. इसके डबल बॉन्ड को इसके डबल बॉन्ड से मैच कर दो एंड मेक द होल प्रोडक्ट. यू विल गेट द मेन प्रोडक्ट और फ्रॉम वेयर इट हैज स्टार्टेड और मेन रिएक्टेड दैट इट हैज स्टार्टेड. देखो इसके डबल बॉन्ड को इसके डबल बॉन्ड से मैच कर दो. CH3H CH3 CH3. ऐसा कुछ दिख रहा है क्या? कैन यू सी एनी ऑफ दीज थिंग्स हियर? तो अच्छा, alkene A on reaction with O2 gives propanol and in equimolar. अच्छा ठीक है. Addition of HCl to alkene A. अच्छा अब इसी A में क्या करना है तुम्हें? HCl को ऐड करना है. ठीक है. Gives B. अच्छा अब ये आपको B देगा. How do you do? HCl को जब यहाँ पे तुम करोगे, so you have to do see that where there is more positive and where there is positive more stable. I hope you can see that positive is more stable. So send the negative part here. So what will happen? H plus will attack here only. So it will give C H CH3 single bond C CH3 CH3 and Cl. So this is what? This is our B. This is the product B. This is the product B. So what is there? So B as the structure of product B will be. Can you see? C CH3 Cl. So CH3 CH3 CCl is H2. Option C is the correct option. You can just check once. Next. In the reaction with HCl, an alkene reacts in accordance with the Markovnikov rule to give product 1-chloro 1-methyl cyclohexane. The possible alkene is, जरा ध्यान से देखो, just do the Markovnikov only. Now just do HCl का यहाँ पे तुम्हें addition करना है. Where positive is more stable? Positive here. So what you have to do? CH3. तो यहाँ पे positive आने के बाद, is there any possibility that it can do any kind of carbocation rearrangement? No, not possibility. So what we can say, because it is already 3 degree, Cl minus will attack here and it will convert into CH3 and Cl. What is the name of this? Its name is 1-chloro 1-methyl cyclohexane. So ये तो दे रहा है, तो option A is the correct option. Is there any other possibility? Check कर लो क्या? अच्छा, A and B is also possible. चलो देखो यहाँ पर देखो, where there is positive more stable, यहाँ पे या फिर यहाँ पे. I hope you all can see that this is more stable because it is 3 degree. तो इसको ऐसे ब्रेक करो, नेगेटिव यहाँ पे लाओ, यहाँ पे हाइड्रोजन, यहाँ पे पॉजिटिव आएगा तो Cl माइनस कहाँ पे अटैक करेगा? यहाँ पे. हाउ इट विल बी फॉर्मेशन? CH3Cl. So it is also the same thing. So means A and B both will be the correct options. Next, a single compound of the structure this is obtained from ozonolysis of which of the following? Okay, can you see? देखो सबको ब्रेक करके चेक करना पड़ेगा. CHO को हम लोग कैसे देख सकते हैं? You can just see something like that. C double bond OH. चलो देखो, बस सिंपली मैंने क्या बोला था, व्हाट यू हैव टू डू, जहां पे भी ओ ओ दिख रहा है, वट एवर यू हैव ओ ओ, उन दोनों को मैच कर दो, इस ओ को इस ओ से मैच कर दो, अब पूरा मॉलिक्यूल बना दो, यू विल गेट द सेम इनिशियल प्रोडक्ट, इनिशियल रिएक्टेंट. कैन यू सी? तो हाउ मेनी कार्बन्स आर देयर? 1 2 3 4 5. 5 कार्बन इज गोइंग टू बी. तो 1 2 3 4 5. 5 कार्बन में चलो डबल बॉन्ड किसी भी एक जगह पे लगा दो. चलो इन दो कार्बन के बीच में डबल बॉन्ड लगने वाला है, इसके और इसके बीच में. सो वेयर इज द मिथाइल? सो वेयर देयर इज डबल बॉन्ड, वहीं पे एक CH3 ऐड होगा. यस, ओके. Another is going to be 1 2 3. After 3, 1 2 3. Here there is going to be one methyl, and then 4 5, nothing else. So this is the whole thing that you have to see. कहां पर है ये भाई? कहीं आपको दिख रहा है? Can you see this? हाँ, ऑप्शन डी इज द करेक्ट ऑप्शन. क्या मैंने बोला? हमेशा याद रखो, अगर इनिशियल रिएक्टेंट पूछा है तो जहां से तुमने ओ ओ, डबल बॉन्ड ओ पार्ट है, डबल बॉन्ड ओ को मैच कर दो, ओ को हटाओ, रिमूव द ओ, दैट्स डबल 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 बॉन्ड को ऐड कर दो. नेक्स्ट, द टोटल नंबर ऑफ पाई बॉन्ड इलेक्ट्रॉन्स इन द फॉलोइंग स्ट्रक्चर. देख लो यार, पाई बॉन्ड आई होप यू ऑल नो हाउ टू फाइंड आउट. यू कैन जस्ट डू दैट. 1 2 3 4. the total number of pi bond electrons in every electron, how many electrons are there? 2. so 4 pi, so 8 pi electrons. So option A is the correct option. Next, the reaction of C6H5 CH double bond CH3 with HBr produces. okay, इसके साथ HBr का प्रोडक्शन होगा, तो जरा फिर से सोचो, H प्लस Br माइनस, वैसे ब्रेक करो. क्या आपको दिख रहा है यहाँ पे? पॉजिटिव मोर स्टेबल बिकॉज इट इज बेंजाइलिक कार्बोकेटाइन, बेंजाइलिक कार्बोकेटाइन. सो नेगेटिव को यहाँ पर लाओ, नेगेटिव आएगा मतलब HBr यहाँ पे जाएगा, HH यहाँ पे जाएगा, Br माइनस यहाँ पे आएगा. C6H5 CHBr CH2 CH3. so option which option is correct? I hope you all can see that option D should be the correct one. Next one, which of the following compounds exhibit cis trans geometrical isomerism? butanol 1 2 3 4, butanol OL. ना cis trans के लिए डबल बॉन्ड तो है ही नहीं यहाँ पे. नो. 2 butane 1 2 3. इज देयर एनी पॉसिबिलिटी? नो. 1 butane, अरे क्योंकि ये कुछ ऐसा है. नो. 2 butanol 2 butanol. so can you see? क्या ये करेगा? नो. there may be, but of course we cannot say because it has not given कि 2 butanol, butane to all. so 2 butanol, 2 butene, can you see? 2 butene is the better one to go with because here it is trans, here it is cis. so cis trans can be shown in D, option D. not a big deal यार. cis trans आप जानते हो, when the same group on the same side, cis different group different side, trans. now the compound this on reaction with NaIO4 in presence of KMnO4 gives. can you see? KMnO4, जब भी KMnO4 दिया है, then you will do the oxidative, just reaction product same as oxidative in ozonolysis. oxidative ozonolysis. ऑक्सीडेटिव ओजोनोलिसिस में क्या होता है? जहां पे भी CH बॉन्ड लगे वहां पे बीच में एक और ऑक्सीजन डाल दो, दैट्स इट. चलो जरा ध्यान से सोचो. पहले तो रिडक्टिव ओजोनोलिसिस में क्या होता है? OO. ये कैसा होगा? CH3C डबल बॉन्ड O. आई एम जस्ट गिविंग यू शॉर्ट ट्रिक्स, नॉट द होल मैकेनिज्म. C डबल बॉन्ड O. इफ देयर इज H को सीधा मत लेकर के आओ, टेक दिस H विथ C. wherever there is CH bond, put one OH into it. तो CH3COOH plus CH3COO. so CH3CO CH3 plus CH3COH. option C is the correct option. which of the following reagent convert propene to 1 propanol? propene to propene 1 2 3. propene को propanol 1 propanol में, can you see? it wants to convert it into OH. can you see? OH on that side where there is, can see, more number of hydrogen, मतलब anti Markovnikov addition. क्या होने वाला है? एंटी मार्कोनिकॉव एडिशन. एंटी मार्कोनिकॉव एडिशन कैसे होगा? एंटी मार्कोनिकॉव एडिशन तभी हो सकता है, ओनली देन इट इज पॉसिबल व्हेन देयर इज हाइड्रोबोरेशन ऑक्सीडेशन. हाइड्रोबोरेशन ऑक्सीडेशन कहां पे है? कोई ऑप्शन है क्या? ऑप्शन डी, B2H6H2O इन द प्रेजेंस ऑफ OH माइनस के प्रेजेंस में जब आप ये रिएक्शन कराते हो तो इट विल गिव यू व्हाट? दिस. यस और नो? एनी दिक्कत? नो दिक्कत. आगे बढ़ो. करेक्ट ऑर्डर ऑफ स्टेबिलिटी करेक्ट ऑर्डर ऑफ स्टेबिलिटी। अच्छा हाँ, अगर इसी का आपका मार्कोनी कोऑर्डिनेशन कराना हो तो क्या करा दो, ऑक्सी मर्क्यूरेशन डीमर्क्यूरेशन, ओएमडीएम यूज करना। ओएमडीएम तब यूज करना जब तुम्हें मार्कोनी कोऑर्डिनेशन कराना हो, एंटी मार्कोनिक ऑफ हाइड्रोबोरेशन ऑक्सीडेशन। आई होप यू ऑल नो दैट। करेक्ट ऑर्डर ऑफ स्टेबिलिटी, स्टेबिलिटी के लिए हमें क्या देखना होता है, फर्स्ट ऑफ ऑल नंबर ऑफ अल्फा हाइड्रोजन, सिस 2 ब्यूटीन, 1 ब्यूटीन, ट्रांस 2 ब्यूटीन। चलो देखो जरा, ब्यूटीन 1 2 3 4, 1 ब्यूटीन में कितने अल्फा हाइड्रोजन, 2 अल्फा हाइड्रोजन। चलो अब ट्रांस 2 ब्यूटीन एंड सिस 2 ब्यूटीन, जरा ध्यान से देखो, इधर 3 इधर 3, 6 अल्फा हाइड्रोजन, हियर आल्सो 6 अल्फा हाइड्रोजन। इट इज व्हाट, ट्रांस, it is what, cis mein can you see that there is going to be repulsion, but trans mein there will be less repulsion. So trans 2 butane is more than, cis is more than here, because this is least number of alpha hydrogen, so minimum stability will be for this. So trans is more than cis, and then 1 butane is least. Next, the correct structure of trans 2 hexanal, hexanal matlab number of carbon should be 6, 1 2 3 4 5 6. okay, trans hai ya cis hai, can you see there is H here, the same group at the opposite side, so of course it is trans, of course it is what, trans. Can you see yahan par kya dikh raha hai aapko, H, and anyways hexenol, not hexanol, so there is no double bond, so wrong. So there is double bond, but there is cis part, can you see, H same, H, both same at the same side, so it is cis. तो बात ही छोड़ो, option A is the correct option. और आगे बढ़ो, the alkene Sai Datta Suryavanshi. Suryavanshi, if you have any question, please do not ask me here, because it is, rapid revision session. Here I cannot take all the question. If you have any doubt, please post all those questions with the timestamp in the comment box. I will take those questions, okay, and I will answer you there. So please, because you know that here speed is of very much essence, very importance. So the alkene RCH-CH2 reacts readily with V2H6 and form the product B, which on oxidation with alkene hydrogen peroxide produces, can you see, it is nothing but hydroboration oxidation reaction. What will happen, anti-Markovnikov addition. If anti-Markovnikov addition is taking place, what will happen, can you see, anti-Markovnikov addition मतलब यहाँ पर वहाँ OH वहाँ लगाओ जहाँ पे number of hydrogen is more, तो OH आपको यहाँ पे लगाना है, H आपको यहाँ पे लगाना है, तो RCH2 CH, so फिर RCH2 CH2OH, RCH2 CH2OH, option B is the correct option. Any दिक्कत, no दिक्कत, very good. Next, alkynes के बारे में, they are unsaturated, this triple bond is there, CnH2 and -2 is this, everything I hope you all understand. Next, coal-based electrolysis can be used for preparation of which of the following hydrocarbon? Alkanes, yes, of course we can use alkane like coal-based electrolysis की बात हो रही है. coal-based electrolysis में कुछ बातें याद रखो यार हमेशा आप, जैसे कि ऐसे करो, RCOOH, अगर आपने RCOH ले रखा है या फिर RCONA ले रखा है, let's say RCO, some of the sodium acetate or any of the salt is there, इसके साथ आपने क्या ले रखा है, वाटर. इसको आप क्या करते हो, आप इसको क्या करोगे भाई, इलेक्ट्रोलिसिस कराओगे. इलेक्ट्रोलिसिस से इसमें क्या बनेगा, RCOO माइनस, प्लस क्या बनेगा, Na प्लस, इससे क्या बनेगा, H प्लस, इससे क्या बनेगा, OH माइनस. प्लीज रिमेंबर कि इलेक्ट्रोलिसिस में only the negative part goes on the anode, so which negative part will go, RCO minus, OH minus will not go, because again because यहाँ पे आप क्या देखते हो, माइग्रेशन टेंडेंसी मैक्सिमम, मोर फॉर दिस लेस फॉर दिस. Na प्लस और H प्लस में कौन जाएगा, H प्लस. वाई, बिकॉज इसका SRP is more. We have already studied in electrochemistry all these concepts very we have studied it thoroughly. So H plus it has more SRP, so it will go on the cathode. So cathode पर जाएगा तो यहाँ से तो हाइड्रोजन गैस निकल जाएगा at cathode. But what about that, when it will go, then it will go RCOO minus. RCO minus is there, so it will remove the electron, because there what will happen at anode, what happens at anode, oxidation takes place. At anode oxidation takes place. जैसे इलेक्ट्रॉन निकलेगा यहाँ पे क्या बचा रहेगा, 1 इलेक्ट्रॉन, because there were 2 electrons, तो 1 इलेक्ट्रॉन को अगर रिमूव करोगे यहाँ पे 1 इलेक्ट्रॉन, what will happen, this R will break homolytically to give 1 1. Here what will happen, carbon has 1 and oxygen has 1 1, what to say, free radical, it will convert into carbon dioxide will be free and R free radical, because there will be not only one R free radical but another R free radical will also be there. So RR, that is nothing but it is just same as the whatever we have studied, you know, in the Woods reaction, and those reaction, whatever was the product, same product will be formed here also. So whatever is the R part, this will be, you know, just coupled symmetrically. तो क्या alkane बनता है? हाँ. क्या alkene बन सकता है? Yes, alkene can also be formed. How alkene can be formed? Let's say RCOONA, or we can say CH2 CH2 C double bond ONA. यहाँ पे क्या हो जाएगा? इसको भी ब्रेक करो, make the free radical, it will convert into CH2 double bond CH2. क्या alkene बना? हाँ, alkene भी बना. क्या alkyne बन सकता है? हाँ, alkyne भी बन सकता है. CH double bond CH, C double bond ONA and C double bond ONA. इसका भी जरा खुद से कर दो वही इलेक्ट्रोलिसिस. क्या करोगे? Break this bond, give this free radical, give this also free radical, it will convert into CH triple bond CH. So it is also going to be converted into alkyne. So all of the above is possible. All of the above is possible. So please remember, when you are doing the coal-based electrolysis, all the things are possible. Next, in which of the following carbides will give the acetylene on hydrolysis? Please remember, very important, that here calcium carbide gives the on hydrolysis gives CH triple bond CH, while Be2C and Al4C3, if you give H2O or Be2C को अगर तुमने दिया, here what will happen? It will convert into how many carbon? Methane. It will convert into methane. Here how many carbons are there? 4, 3. So what will it? CH3, CH2, CH3. Propane will be formed. So here alkanes will be formed in Be2C and Al4C3. But if it's CaCa2, here it will be formed. Calcium carbide will form this acetylene. Any dikkat? Next. These things you have to remember, please. If any doubt is there, NCERT, go through it. CH3, CHCl, NaNH2. NaNH2 does what? It is going to do elimination reaction. Elimination reaction, that too how many times? It can do 2 times also elimination. Okay, because it is a very, you know, strong base we are using. NaNH2 is a strong base. So 2 times beta elimination. Just do that. How many bonds will be there? 2 extra double bond or 2 extra pi bonds will be there. So 1 and 2. 2 times. So minus of 2 times HCl will be removed. What will be formation? CH, triple bond C, CH3. This will be the product. So option C is the correct option. Next, this one is giving trans 2-butene, cis 2-butene. When trans 2-butene in the presence of A, in presence of B. A means A is going to be what? Lindlar's catalyst. I hope you all, sorry. Trans के लिए there is going to be Birch reduction. मतलब sodium and liquid ammonia. While in case of B, here cis butene. Cis कब होता है? Cis will be there when there is going to be, you know, Lindlar's catalyst. चलो आ जाओ देख लो. H2PD BaSO4. H2PD BaSO A is going to be liquid ammonia and sodium. Okay, it is correct. B is going to be PDBaSO. Yes, option B is the correct option. Any doubt? So because here I hope it is Birch, while here Lindlar's catalyst. आगे बढ़ो. Which of the following compound will not give hydrocarbon on reaction with Grignard reagent? Please remember, whenever RMgX reacts with acidic hydrogen containing compound, it gives RH. RH is what? It is alkane. So, or alkane is nothing but hydrocarbon. चलो आओ जरा ध्यान से देखो. Can you see? Is there any acidic hydrogen? Yes, there is alkyne. Alkynic के terminal hydrogen. Alkyne का terminal hydrogen of alkyne is acidic. Can you see? Is there triple bond is there, but there is no terminal hydrogen. यार देखो, triply bonded carbon पे hydrogen नहीं है. It is what? It is sp3 hybridized. It is what? It is sp hybridized carbon. But this is what? This is sp3 hybridized carbon. So this hydrogen is non-acidic. It is non-acidic. If it is non-acidic hydrogen, so can it give this reaction? No, this will not give. So option B, not give ना? हाँ, correct. जबकि यहाँ पर देखोगे, so can you see that there are 2 hydrogen, but you see after removal of hydrogen as the H plus, what will happen here? Here minus will come. That will make it more stable. Basically, it will make it aromatic. It will make it aromatic. So because of the formation of aromatic compound, it will be more stable. So of course, it will easily remove the hydrogen. So therefore, this will be okay. ये आपका बिल्कुल सही है. Because it is called quasi, you know, quasi aromatic substances that after donation of H plus they can convert into aromatic substances. Here what we can say, wherever this OH bond is there, NH bond is there, SH bond is there, HX bond is there, H or halogen bonds are there, so all those hydrogens are acidic hydrogens. So of course this can also give, only B cannot give. आगे बढ़ो. The number of sigma and pi bonds in the pent-2-ene 4-ine, please make it and just find out, not a big deal, you can do it, I know. In the following reaction, CH3C triple bond CH, red hot iron tube. Please remember that this is something whenever there is alkyne and this is giving, it is for aromatization. It is for aromatization. Aromatization होता है तो क्या होता है? अगर यहाँ पे acetylene होता, so 3 moles of acetylene gives benzene. But if you take this, what it will convert into? It will convert into CH3, 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 CH3. You can just find out how many number of sigma is there. Please, that is something that is for you. You can do it, I know. Next, which one of the correct order of acidity? Correct order of acidity, I hope you all know that SP, the more the percentage is character, more the acidity is there. So where there will be triple bond, more acidity. Can you see triple bond is there? Percentage SP. So here it is, SP is there. But of course we can see that at one side it is plus I. Plus I decreases the acidic strength. Here what is there? It is SP2. Here what is that? It is SP3. So of course here it will be correct because maximum here SP but with plus I. Here SP2, here SP3. So option A is the correct option. Next, which of the following organic compound has the same hybridization as its combustion product, carbon dioxide? Okay, carbon dioxide का क्या है भाई? Carbon dioxide. Can you see what is the hybridization of carbon dioxide? It is how many sigma? 1, 2. So it is SP hybridized. So what is something that has the SP hybridized? Can you see ethane? Ethane has SP3. Ethine has SP. Ethene has SP2. Oh, option B is the correct option. क्योंकि जब आप इसे when you are going to give O2 to this, consider ethine is there. How? CH triple bond CH. If you give O2, what it will convert into? Carbon 2 CO2 plus how many of the hydrogens are there? 2. So how many of the H2O will be formed? 1. So how much of oxygen is there? 5 plus 5. So it will be 5 by 2. So this is the reaction. So there, this is also SP and this is also SP hybridized. Okay, any doubt? चलो आगे बढ़ो. In the following reaction, CH triple bond CH H2 HD H2SO4 plus Hg plus. Please remember, कि in the presence of H, when there was alkene, alkenes do the electrophilic addition reaction faster, but in case of alkyne they do it slower, and because they are slow reactions, तो उनको थोड़ा catalyze करने के लिए we have to put Hg plus 2 or HgSO4. So basically HgSO4 here used as the catalyst for the reaction. So Hg plus we have to use. How the whole reaction goes, I will not go to the mechanism, directly I will tell you. First of all, break this bond. पहले ऐसा बनाओ कि जहां पे मोर पॉजिटिव, ज्यादा स्टेबल पॉजिटिव कहां बन रहा है? कैन यू सी? अब इसको ब्रेक कर दो एक बॉन्ड, इस पे किसी को माइनस दो, किसी को प्लस दे दो. देन H2SO4 कैसे ब्रेक करो? आई होप यू ऑल सी दैट. बेसिकली आपको लेना क्या है? H प्लस एंड OH माइनस. OH माइनस कहां दो? H प्लस को दो, कहीं पे भी OH माइनस को दो, वहां पर जहां पे ज्यादा CH. Here it is going to be OH, CH double bond, CH2. Can you see? But it is what? It is enol. It is what? Enol. Enol का यहाँ से क्या हो जाएगा? enol से ज्यादा स्टेबल. जनरली अगर हाइड्रोजन बॉन्डिंग या फिर कोई भी कंजुगेशन या फिर कोई और रीजन नहीं है तो जनरली enol प्रोडक्ट इज लेस स्टेबल एंड कीटो प्रोडक्ट इज मोर स्टेबल. तो ये टॉटोमराइज होकर के enol फॉर्म विल कन्वर्ट इनटू कीटो फॉर्म. सो व्हाट विल हैपन हियर? 1,3 C डबल बॉन्ड O H single bond C CH3 CH3 CO CHO CH3 CHO CH3 CHO will be formed. Now ये जो P है प्रोडक्ट P will not give. अब ये P क्या नहीं देगा? Can you see iodoform test? Can it give iodoform test? Yes. Can you see CH3 CO part is there, so this will give iodoform test तो ये देगा. Tolerance reagent test. Tolerance reagent क्या ये एल्डिहाइड है? हाँ एल्डिहाइड है. एल्डिहाइड है तो क्या टॉलेंस reagent test देगा? हाँ देगा. Brady's reagent test. Will it give the Brady's reagent test? Yes, Brady's reagent test is given by aldehydes. Victor Mayer test? No, Victor Mayer test नहीं देगा क्योंकि it is given by alcohols. But what we have here? We have the aldehyde. Okay, चलो आगे बढ़ो. Predict the product C obtained in the following reaction. This plus HCl. फिर से वही करना है भाई, कोई बड़ी बात नहीं है. सबसे पहले how many moles of HCl is there? 1 mole. How do you do? देखो यहाँ पर भी देखो बहुत प्यारा रिएक्शन है. द मैकेनिज्म वेरी ब्यूटीफुल, बट स्टिल अगेन आई विल टेल यू फॉर मैकेनिज्म गो थ्रू NCERT, गो थ्रू मैनी अदर प्लेसेस, अदर सोर्सेज, बट बिकॉज इट इज अ फास्ट Here we have to go faster. What do you have to do? Again do plus and break into plus and minus. Here can you see, here plus is more stable, here negative will be more stable. तो चलो इस पाई बॉन्ड को ऐसे डिलोकलाइज करो कि नेगेटिव यहाँ पे आए प्लस यहाँ पे आए, H प्लस Cl माइनस, तो Cl माइनस को यहाँ पे अटैक कराओ, H प्लस को यहाँ पे अटैक कराओ. व्हाट विल बी कन्वर्ट इनटू, इसको मैं ET बोलूंगा, इथाइल CCl एंड ट्रिपल बॉन्ड, जस्ट मिनट, इथाइल CCl डबल बॉन्ड CH2. अब उसके बाद आपने क्या किया, H प्लस HI का अटैक करा है, HI का अटैक करा है, HI का अटैक कराओगे तो क्या होगा, अगेन see where positive is more stable. I can see that positive is more stable here. Why? Because fluorine has the lone pair, and due to the lone pair it is back bonding resonance stabilized, very stable. So what we can say, नेगेटिव को इधर भेजो, यहाँ पे नेगेटिव भेजोगे तो H प्लस माइनस में ब्रेक करो, H प्लस को इधर भेजो, I माइनस को इस पे भेजो, तो ET CiCl सिंगल बॉन्ड CH3, तो ET CiCl CH3. Option C is the correct option. Next, reduction of 2-butene with sodium is in liquid ammonia gives, I hope you all remember, trans-2-butene. Birch reduction. Aromatic hydrocarbons. Aromatic hydrocarbons, I hope you all know that. I do not have to explain what is aromatic hydrocarbons. Directly I will come to the question. What will be the product? Can you see it is nothing but RMGX. It is Grignard reagent. Grignard reagent. Is there any acidic hydrogen? Yes, there is acidic hydrogen. In acidic hydrogen, what I told you, whenever there is RMGX plus acidic hydrogen is there, it will convert into RH because it breaks into R minus MgX plus. Yes or no? So here it will be something like that. R minus H plus को जोड़ करके RH बना दो. क्या आप यहाँ पे भी वही सेम कर सकते हो? It will be there minus MgBr plus. क्या यहाँ पे देख रहे हो? Plus इसको कर दो minus. So again, what will be there? It will be rather than benzene, rather than this word negative positive, it will form the benzene. तो ऑप्शन सी. साथ में क्या बन जाएगा, व्हाट विल बी द साइड प्रोडक्ट, इट विल बी CH3O MgBr minus plus. Okay, this is something that will be the side product. चलो आगे बढ़ो. Next, chemical properties of arenes. Chemical properties of arenes, directly I am telling you, it gives the electrophilic aromatic substitution reaction. Now in nitration of benzene, which of the following reagent behave base during the electrophile? Always remember, in nitration, what is the electrophile we use? We use NO2 plus. How does this NO2 plus, please remember, forms when HNO3 reacts with H2SO4. H2SO4 being more acidic, it will act as the acid, then it will have to act as base. Then HNO3 acts as base. You will say, sir, HNO3 is an acid, or it is acid only up to when it is not facing a stronger acid, because H2SO4 is a more stronger acid, so it will act as the base. So basically this will be something like that, HN double bond O H and O, and there is what, H2SO4, because which is acid? H2SO4 is acid. If H2SO4 is acid, what will happen? It will break into O minus H plus. What will happen? Can you see there is oxygen? Oxygen will do what? Oxygen here can, or we can say, sorry, not this oxygen. This oxygen will take this H plus, because oxygen has the lone pair. As it has the lone pair, it will attack on it and it will take this. What it will convert into? It will convert into, can you see, HSO4 minus of HSO4 minus, and साथ में क्या बन रहा है? N double bond O H O पे आया positive and O. Can you see this will, what happened here? Here what will happen? Here NO is there. So this will be given to oxygen, because oxygen is more stable, sorry, more electronegative, positive charge on that is not a good thing. What will happen? The H2O will be removed, and what will be the formation? Because nitrogen here gets the NO2 positive. So this is something that is nitronium ion that will be formed in the whole reaction, and this will attack on the benzene ring because there is the delocalized pi electrons are there. So चलो आ जाओ यहाँ पे देखो. So H2SO4 is acting as acid, HNO3 is acting as base because it is asking for base. Okay, आगे बढ़ो. Here, what is the major product? What is the reaction? First of all, I hope you all remember, it is nothing but, it is Friedel-Crafts alkyl, sorry, not halogenation reaction, sorry, halogenation reaction. What it will convert into? Because FeBr2 is here acting as the Lewis acid, it will take Br plus and Br minus, break it into Br plus and Br minus. FeBr4 माइनस प्लस साथ में क्या करो Br प्लस, इस Br प्लस को कहां पे अटैक करा दो, इस पे अटैक कराओगे। अब इस पे कहां पे अटैक कराओगे, बिकॉज यू कैन सी दैट दिस इज ऑल्सो ऑर्थोपैरा, दिस इज ऑल्सो ऑर्थोपैरा, तो कहां पे अटैक करेगा, यहाँ पे ऑर्थो है इसका, यहाँ पे पैरा है इसका, ऑर्थो यहाँ पे और इसका पैरा यहाँ पे है। So what we can say that we should make Br minus Br plus at that place where there is least hindrance is there. अगर यहाँ पे Br आएगा तो this will be very much in hindrance, CS3 दोनों से बहुत hindrance होगा, तो ऑर्थो पे मत भेजो, पैरा पे भेजो, किसी एक के पैरा पे भेज दो। कैन यू सी, तो किसी एक के पैरा पे भेजोगे तो क्या हो जाएगा, आई होप यू ऑल यू कैन अंडरस्टैंड, यहाँ पे भेज दो, it will convert into CH3 and Br. Okay, is there any option given? Yes, option C. Next, the enthalpy of the hydro, देखो एक और बनेगा, ऐसा नहीं है कि बस यही बनेगा, साथ में आपका ये प्रोडक्ट बनेगा CH3 and here Br, but this will be minor while this will be major. Okay, चलो आगे बढ़ो. Next, the enthalpy of the hydrogenation of these compounds will be in the order of, okay, it is a very easy one because enthalpy of hydrogenation, or we can say heat of hydrogenation, yesterday we have studied it very in thorough way. Heat of hydrogenation is inversely proportional to stability, where stability will be more, जहां पे stability ज्यादा होगी वहां पे heat of hydrogen will be less. Can you see, heat of hydrogenation के लिए आप सीधा यहाँ पे क्या देखोगे, can you see, it is what, aromatic, it is what, aromatic, as well as aromatic के साथ ही साथ आप देख सकते हो how many of the alpha hydrogens are there, hyper conjugation के लिए 9 alpha hydrogens are there. Can you see here what is happening, can you see, it is not aromatic but it is having one conjugation is there, not, but it is non aromatic, so ये तो कम stable हो जाएगा ना, it is most stable first. और यहाँ पे अगर अल्फा हाइड्रोजन भी देखोगे, how many alpha hydrogens are there, 6 alpha hydrogens are there. Can you see, अच्छा not just 6, यहाँ पे भी देखोगे more than 6 is there, but anyways plus 2, 8 alpha hydrogen is there. Okay, what about this, can you see here is there any kind of conjugation, no, so no conjugation is there, because no conjugation is there, so stability will be less, so least stable is this, so सबसे ज़्यादा heat of hydrogens will be for 3, then 2, minimum for this because it is most stable, so minimum for 1, maximum for 3 is more than 2 is more than 1. Next आगे बढ़ो, which of the following chemical system in is non-aromatic, is non-aromatic, can you see this, is it aromatic or non-aromatic, can you see this part, it is sp3 hybridized, because it is sp3 so no conjugation, if it is no conjugation so option A is the correct option. Can you see, this is aromatic, aromaticity के लिए होता क्या है, शर्त क्या है, what is the condition, aromaticity condition, can you help me with that, हाँ चलिए बताइए. Yes, first of all there should be a pi conjugated ring should be there, then how many of the pi electrons should be there, it should follow Hugel rule, Hugel rule should be followed. Hugel rule कैसे follow होगा, it should be by like 4n plus 2 pi electrons should be there, here n should be equal to 0 1 2 3 ... okay, and it should be planar, ऐसा नहीं हो कि नॉन प्लेनर हो जाए, प्लेनर मतलब no sp3 hybridized atom should be there. okay, चलो आ जाओ देख लो कि यहाँ पे तो sp3 हो गया तो इसकी बात ही मत करो, नॉन एरोमेटिक हो गया, ये देख रहे हो ये रिंग है, कंजुगेटेड है, 4n plus 2 means how many, 6 pi electrons is also there, so of course this is yes. यहाँ पर देखो 10 pi electrons are there, प्लेनर है, कंजुगेटेड है, yes aromatic. Can you see here सल्फर के पास दो 2 outside and 2 inside, this is in conjugation, so therefore 6 pi electrons are there, so this is also what, aromatic. Next, some meta directing substituents in the aromatic substituent are given, which of the most meta deactivating. Acha, always remember all meta directing are deactivating. चलो देखो meta deactive, last day we have studied about plus m and minus m effect, yes or no, So here, which is most meta deactivating or meta directing and most deactivating? Nitro. Nitro is more than cyanide. Yes or no? Remember, आगे बढ़ो. Which of the following compound will not undergo Friedel-Crafts reaction easily? देखो, जहां पे भी that will decrease the rate of reaction. So which will not undergo something if deactivating group is present. If deactivating group is present, is there any deactivating? Can you see nitrobenzene? So nitro is what? It is meta and deactivating group is there. So therefore this will not give Friedel-Crafts reaction, because Friedel-Crafts reaction is a electrophilic aromatic substitution reaction. Okay, in the following reaction C6H5 CH2Br, this the product X. अच्छा, यहाँ पे आपको दिख रहा है कि ये क्या है? It is Mg and ether. Means first of all you have to form, first step is formation of, always remember, Rx plus Mg and ether converts, it is the formation of Grignard reagent. So first step is going to be C6H5 CH2. अब देखो यहाँ पे क्या है, Rx था, ये किस में बन जाता है? RMgx. तो RMgx, सॉरी, इसको कैसे ब्रेक करना? R माइनस mgx, ऐसा तुम्हें कुछ करना है. तो कैन यू सी R, इट इज R पार्ट, R बीच में क्या ले आओ? Mg, साथ में क्या लाओ? X. इसको क्या कर दो? माइनस, इसको क्या कर दो? प्लस. Now what will be there? The next part is going to be H3O plus. Can you see H3O plus will give H plus. अगर H plus देता है तो क्या करते हैं? इसका इस पे अटैक करा दो, C6H5 CH2 माइनस H plus. अरे CH2 minus H plus का मतलब CH3. तो C6H5 CH3. So what is that? It is toluene. Next, easy है भाई, tough नहीं है. Which of the following species is not electrophilic in nature? Not electrophilic in nature means something that is not going to go for electro, where there is, it can take electron. It has the vacant d orbital. Of course it will go. Here NO2 plus, of course it is electrophile. Electrophile for nitration. Is it for chlorination? For chlorination. BH3, can you see boron has the vacant p orbital? Can you see? And octet incomplete. What about H3O plus? Can you see? Oxygen is here. Octet is complete. Even though it is positively charged, do not go into the trap. It is positively charged, but it is not the electrophile. Why? Because octet complete. Next, which of the following is most reactive towards electrophilic attack? Electrophilic attack के लिए वो ज्यादा reactive होगा जहां पे negative charge inside the ring is maximum. Negative charge inside the ring will be maximum when the plus M effect will be there. Most reactive means there should be plus M effect. Is there plus M effect? क्या आप इसको देख पा रहे हो? Is it giving plus M effect? No. Is it giving plus M effect? Yes, because it is having lone pair. Is it giving? No. It is what? Minus M. It is minus M. It is plus M. I hope option C is going to be most. यार इसकी बात करो, ये Cl की बात करोगे तो Cl is also plus M, but it is also having minus I, and यहाँ पे minus I becomes stronger than plus M. So यहाँ पे rather than being activating, it becomes deactivating. But साथ ही साथ it is ortho and para directing also at the same time. So due to plus M it is ortho para directing, but due to minus I it is deactivating. Very important point to keep in mind. So option C here is the correct option. Now, which order is decreasing reactivity towards the electrophilic reagent for the following? Benzene, toluene. Toluene में there is going to be plus H of CH3. Chlorobenzene minus I and plus M. But here minus I wins and plus M. Phenol, there is going to be OH. It is what? Plus M. So most reactive is going to be phenol and then toluene, because there it is plus M, यहाँ पे plus M. Plus M is stronger than plus H. So 4, 2, 1, 3. 4, 2, 1, 3. 4, 2, 1, 3, because it is deactivating. It is deactivating. I hope you know what is this activating and deactivating. So 4, 2, 1, 3. 4, 2, 1, 3. 4, 2, 1, 3. Option C. Next, 4 structures are given in option 1 to 4. Examine them and select the aromatic structure. Can you see how many? Is it ring? Yes. Is it conjugated? Yes. So how many of the 2 pi electrons are there? Of course it is what? Aromatic. Yes, it is aromatic. So what it is giving? Examine, select the aromatic structure. Yes, it is aromatic. It is non-aromatic. It is cyclooctatetraene. So it is a non-aromatic due to non-planarity. This is non-planar. What about this? How many of the electrons are there? 4 pi electrons are there. Though conjugation is there, but it is 4 pi electron. Anti-aromatic. Anti-aromatic. What about this? There it is going to be Areyar. It is also. So here it is going to be select aromatic structure. This is also aromatic. This is also aromatic. Okay. Next. So that is all for today class. I hope whatever we have studied today, you have understood it and you are going to work with it even better, even with the more contents. But whatever the question we have selected today, these are most selected question, because these type of question keep on coming again and again. So I have selected most important question. Please go through these and practice.